Hello, let's solve this question on calculus. Is about application of integration in kinematics. Kcse 2021, paper 2, question number 24. A particle was moving along a straight line. The acceleration of the particle after t seconds was given by 40 minus 13 meters per second squared. The initial velocity of the particle was 18 meters per second. A. Determine the value of t when the particle is momentarily at rest. So let's do that part. Look at what you're given. The acceleration of the particle was given by this. So acceleration, which is A, is given by 40 minus 13 meters per second. And you're given the initial velocity as 18 meters per second. So it's supposed to determine the value of t when the particle is momentarily at rest. The keyword here, when the particle is momentarily at rest. One important thing that is going to help you in this question is the fact that when the particle is momentarily at rest, velocity at that instance is 0. That is when the particle is at rest. Velocity is equivalent to 0. So therefore, this tells us that we must get the expression for velocity. Another thing that is going to help us here, which I'm going to draw, is these. We have S, we have V, we have A. S for displacement, V for velocity, A for acceleration. So if you're moving downwards, for example, you're given displacement S, you're required to get velocity, you differentiate. So you differentiate S to get V. You differentiate V to get A. That is downward movement. You differentiate. That one is very important. Then we come to upward movement. Maybe you're given acceleration. Like in this case, you're given acceleration. Then we require to get velocity because we must get velocity. We're moving upwards. So you're going to integrate. Again, if you're given velocity, you're required to get S or displacement. You're moving upwards, you have to integrate. Therefore, in this question, we are going to integrate acceleration with respect to t in order to get velocity. That is what you're going to do. So we integrate that because we've noted that at rest, velocity will be 0. So we must get this velocity. So very fast, we integrate these. So we're going to integrate 4t. This is acceleration minus 13 with respect to t. It's going to give us v. So when you integrate these, you'll get 4t squared divided by 2. When you integrate 13, you get 13t. Then you have to add constant of integration is equals to v. So this will give 2t squared minus 13t plus c is equals to v. Now what we need to get here is the constant, that is c, the constant of integration. And what is going to help us? We're given the initial velocity. The initial velocity is given as what? As 18. And then at initial velocity, time will be 0 seconds. So if we substitute v is equals to 18 and t is equals to 0 in this expression for velocity, we are going to get the constant c. So this one, when you substitute t is equals to 0 and v is equals to 18, you simply get 18 is equals to v. So we'll get not 18 is equals to v. We are going to get 18 is equals to c. So simply what I'm doing, I'm substituting v with 18, and then where we have t, just substitute that with 0. You'll get c as 18. Therefore, now velocity is going to be given by 2t squared minus 13t plus 18. Now, We are now supposed to determine, now we have velocity, the full expression for velocity, determine the value of t when it is at rest. We just said when the particle is at rest, velocity is equals to 0. Therefore, v is equals to 0 when it is at rest. This is 2t squared minus 13t plus 18. So this one is a quadratic equation, and you can use any suitable method to solve it. So for me, I'm going to use factorization. So look for two numbers. This product is 36 and the sum is negative 13. So these two numbers are negative 4 and negative 9. So therefore we have 2t squared. So let me write negative 13 using negative 4 and negative 9. So negative 4t negative 9t plus 18 is equals to 0. Factorizing these, you have 2t is common. So you have t minus 2, then minus 9 is common. This is a t minus 2 is equals to 0. So 2t minus 9, t minus 2 is equals to 0. So from here, you have 2t minus 9 is equals to 0. And if this is the case, therefore t is equals to 9 over 2 or 4.5 seconds. And then the other one, t minus 2 is equals to 0. So in this case, t is equals to 2 seconds. So the values of t when the particle is at rest is t is equals to 4.5 seconds and t is equals to 2 seconds. So that is how you're supposed to work out the first part. Now part B, find the distance covered by the particle between t is equals to 1 second and t is equals to 3 seconds. The distance. We need to get the distance. So let me go back here where we have S, V, A. So already we have the expression for velocity. Now we need to get the distance. So you can see we are moving upwards here. So in order to get distance given velocity, we are going to integrate velocity with respect to t, and that will give us distance. Now before we proceed doing that, since we shall have to look at the expression for velocity, we just got it here. Velocity was 2t squared minus 13t plus 18 minus 13t plus 18. Before we do that, because you're going to integrate velocity to get distance, and it is between 1 and 3, I will discourage you from directly coming and taking it like this. You integrate from 1 to 3, and this is a 2t squared minus 13t plus 18. When you do this one, at first, you may find yourself coming up with errors. There's something that you need to do before you do that direct integration from 1 to 3. You need to first visualize to see whether there's an area that is lying above the x-axis and the one that is lying below the x-axis. And this is how you do it. You simply need to pick 2 points or 3 points. So you have, you can simply draw a table here. So you have velocity here. So 1, 2, and 3. So because I'm picking 1, 2, and 3 because you're integrating from 1 to 3. And then you can try to substitute 1 here. Just substitute 1 here. When t is 1, this is t, this is v. So when t is 1, what will be the value of v? Just visualize that. Just visualize that and tell me what you notice. Is it going to give you positive or is it going to give you negative? So this will give 2 minus 13. So that will give 7 to be positive. And then you have when it is 2, when t is equals to 2, this will give, when t is equals to 2, this will give 8 minus 13 plus, not 13, 8 minus t is 2, this is 26 plus 18. So when I add these, I'll get 0. So I'm simply substituting t in this expression for velocity. Then when it is 3, when t is equals to 3, this will give 9 times 2, this will give 18 minus 39, then plus 18. So this will give 36 minus this will give negative. So that is negative. Now when you draw a simple sketch, just a simple sketch here, this being the x-axis, this is the y-axis, this is the x-axis. So you have 1, this is 2, and this is 3. So for 1, you realize you'll have a positive when you sketch it. 1, 7, let's say 7 is somewhere here. So 1, 7 will be somewhere there. Then 2, 0 will be here. Then 3, negative 3. So let's say negative 3 will be here. So when you draw these, when you draw a sketch, this is something that you're going to realize, observe here. So there's this part between 1 to 2, it lies above the x-axis. Then between 2 and 3, the area between 2 and 3 lies below the x-axis. So that one tells you that when you're integrating, you need to integrate this one in parts. You integrate from 1 to 2, that one will give you the area above the x-axis. And then separately you add the area between 2 to 3, that is below the x-axis. When you separate them like that, you are going to get an accurate answer. But if you just do a direct integration from 1 to 3, you're going to be wrong, because you made an assumption that maybe the whole of that area between 1 to 3 lies either, the whole of that area lies above the x-axis or below the x-axis. So it is good to visualize this. This one tells you that now we need to break it down into 2, and that is what I'm going to do here. So I'll do that one here. So you integrate, this is what you're going to have. So I will have to integrate from 1 to 2, and I'm integrating this velocity because I want to get the distance. So integrate velocity, you get distance. So this is 2t squared minus 13t plus 18 with respect to t. Then you add the area from between 2 to 3, that is integrating the same, minus 13t plus 18 with respect to t. So that is what you're supposed to do. So let me begin with this area between 1 to 2. So this one, when you integrate, this will give 2t, this will give 2t cubed over 3 minus 13t squared over 2 plus 18t plus c. Then the square brackets, and this is between 1 to 2. So I want to finish with this one first, and this is what you're going to get. So you substitute 2 first, where you have t. So you have 2 thirds, this is 2 cubed minus 13 divided by 2, this is 2 squared, then plus 18, then t is equals to, then plus c, like that. And this one is going to give, when you work it out, 2 thirds, use a calculator, multiply by 2 cubed, this will give 16, 16 over 3, then 13 over 2 multiplied by 4, this will give 26, and then this one will give 36. Now we're going to ignore c, since when we subtract, when we subtract, when we substitute t is equals to 1, c will get eliminated. So therefore, this one will give me see it. This will give 15 and a third. This will give 15 and a third. Now what we've done, we've just substitute 2. Now we substitute 1. We substitute 1. When you substitute 1, you'll get 2 thirds. So this is a 1 cubed minus 13 over 2. This is 1 squared plus 18, 1 plus c, like that. So this one is going to give, when you work it out, this will give 2 thirds minus 13 over 2 plus 18. And when you work out this will give 12 and 1 over 6. 12 and 1 over 6. So that is what you get. So we substituted 2, we got that. Then we substituted 1 here, we got this. So you subtract the 2. So now to get the area between 1 and 2, you take 15 and 1 third minus 12 and 1 over 6. And this will give 3 and 1 over 6. You hold on this one. Now this 3 and 1 over 6 is the area between, or the distance between 1 to 2. The distance between 1 to 2. So from 1 to 2. Now we need to get from 2 to 3. So from 2 to 3. So again, we integrate from 2 to 3. And the same velocity, 2t cubed. So 2t cubed. This is a 2t cubed over 3 minus 13 minus this is 13t squared, then plus 18t. I'm sorry, I just did the integration, direct integration. Let me first write whatever we are supposed to integrate. So you're supposed to integrate 2t squared minus 13t plus 18. That is velocity. That is what you're supposed to integrate with respect to t. And when you integrate, this is what you get: 2t cubed divided by 3 minus 13t squared divided by 2 plus 18t plus c. And then the limits from 2 to 3. Now very first, we start by substituting 3. We start by substituting 3. So we shall have 2 thirds. Then this is a 3 cubed minus 13 over 2. 3 squared plus 18. 3. So we are going to leave out c, because when we subtract, now we have substituted 3. Now let's substitute 2. We subtract these, so this will be 2 thirds. This is 2 cubed minus 13 over 2. This is 2 squared plus 18, 2, like that. Let me write this one properly. So plus 18, 2, like that. So on this side, we shall have 2 thirds times 3 cubed. This will give 18. Then this will 13 over 2 times 9. This will give 117 over 2 plus 18 times 3, you get 54. Then subtract. This is 2 thirds. Now, there's something that you notice. We already did this. When you substitute 2, it is when you substitute 2, we did the substitution for 2. It is here. It is here. It is the same thing that you have here. And we got that one as 15 and a third. We got it here 15 and a third. So there's no need of wasting more time. This is 15 and a third. So we did the whole of that. It is here. It is up here. I've just indicated it is just here. So that will give 15 and a third. So working out these, we shall have 18 subtract 117 over 2 plus 54. These will give 27 over 2. And then subtract 15 and a third. And you notice this one will give you a negative. When you subtract these, you get negative 1 and 5 over 6. Now, you have the two areas. So between 1 and 2, we got 12. This area, we got this area as 12. Was it 12? No, not 12. It was not 12. It was 3. We got it here. It was 3 and 1 over 6. That is the distance between 1 and 2. Then between 2 and 3, we got it here. It is 1. That is negative 1 and 5 over 6. Therefore, the total distance now between 1 to 3 seconds. 1 to 3 seconds. We have done it in parts. So from 1 to 2, we have 3 and 1 over 6. Then plus, you notice that the area or the distance between 2 and 3 is negative. The negative sign implies that it is below the x-axis. But when you're getting the distance, of course, you're going to ignore the negative. The negative only implies that it is located below the x-axis. So we simply get the absolute, and the absolute is this figure without the negative. So we add 1 and 5 over 6. So that will give us the total area. So when you add these, you simply get 5. And because you're getting the distance, this will be 5 meters. When you add 3 and 1 over 6 plus 1 and 5 over 6, you get 5 meters. And that is simply how you're supposed to have done that question. Thank you.